Hi guys, welcome to my study compass. In this video, I'll be walking you through the past paper, Math P3, Variant 2, February-March 2020. Let's get started. Navja works in a post office. The table shows the cost of sending parcels by post. The cost depends on the mass m grams of the parcel. CIE sends each of these 4 parcels by post. He pays with a $20 note. Work out how much change he receives. First, we need to determine how much CIE pays for sending each parcel. The mass of this parcel, which is 55 grams, is in this range, and so the cost of sending this parcel is $0.76. The mass of this parcel, which is 300 grams, is in this range, and so the cost of sending this parcel is $5.60. The mass of this parcel, which is 875 grams, is in this range, and so the cost of sending this parcel is $5.60. The mass of this parcel, which is 250 grams, is in this range, and so the cost of sending this parcel is $2.20. So now the change he receives would be equal to the amount he paid, which is $20, minus the total cost of sending the 4 parcels, which is $0.76 plus $5.60 plus $5.60 plus $2.20. This gives us $5.84. On 1st April, the cost of sending any parcel increases by 5%. Show that the increase in the cost of sending an extra large parcel is $0.28. From the table, we know that the cost of sending an extra large parcel is $5.60. So when we find 5% of $5.60, we get $0.28. Avani says, as the cost of an extra large parcel increases by $0.28, then the cost of a large parcel will also increase by $0.28 to $2.48. Explain why Avani is incorrect. The cost of sending a large parcel, which is $2.20, is less than the cost of sending an extra large parcel, which is $5.60. And so the increase in cost, which is 5% of $2.20, will be less than $0.28. Navja weighs a parcel with mass W kilograms on her scales. She uses the masses shown to balance the scales. Work out the value of W. If the scales are balanced, then it means the mass on the left scale is equal to the mass on the right scale. 5 grams plus 10 grams plus 20 grams is equal to 35 grams. To convert 35 grams to kilograms, we divide by 1000, giving us 0.035 kilograms. So we have W plus 0.035 kilograms equals 2 kilograms. When we subtract 0.035 from both sides, we get W equals 1.965 kilograms. Sometimes, Navja uses an electronic weighing machine. The machine gives the mass P kilograms of a parcel as 12.4 kilograms, correct to the nearest 100 grams. Complete the statement about the value of P. To correct the mass P to the nearest 100 grams, we have 12.4 kilograms. Then we bring in plus and minus 100 grams, which is 0.1 kilograms. Then we divide 0.1 kilograms by 2. So for the lower bound of P, we have 12.4 minus 0.1 over 2 kilograms, which is equal to 12.35 kilograms. And for the upper bound of P, we have 12.4 plus 0.1 over 2 kilograms, which is equal to 12.45 kilograms. So we have P is greater than and equal to 12.35 and less than 12.45. 66 football players each take 5 penalties. The number of penalties that each player scores is recorded. The results are shown in the bar chart. Write down the mode. The mode is the number with the highest frequency. From the bar chart, the highest frequency is 19. The number with this frequency is 1. Write down the range. The range is equal to the highest number, which is 5, minus the lowest number, which is 0. So 5 minus 0 is 5. Calculate the mean. The mean is equal to the sum of all the penalties scored, which is 0 times 16 plus 1 times 19 plus 2 times 14 plus 3 times 10 plus 4 times 5 plus 5 times 2 divided by the sum of the frequencies, which is 66. When we type this into the calculator, we get 1.62 rounded to 3 significant figures. The attendance at a football match is 11,678. Write 11,678 in words. Here is the number written in words. Write 11,678 correct to the nearest hundred. The number in the hundreds position is 6. The number after 6, which is 7, is greater than 5. So we add 1 to 6, giving us 7. The numbers after 6 become 0. So we have 11,700 rounded to the nearest hundred. In a football stadium, there are 15,000 seats. 10,650 of these seats are occupied. Find the percentage of the 15,000 seats that are occupied. To get this percentage, we divide the number of seats that are occupied, which is 10,650, by the total number of seats, which is 15,000, times 100%. This gives us 71%. A ticket to a football match costs $20. Calculate the cost of the ticket in rupees when the exchange rate is 1 rupee equals $0.016. First, we need to set up the currency conversion to find the equivalent of $20 in rupees, which is what we are calling X. When we cross multiply and make X the subject, this is what we have, which is equal to 1,250 rupees. Write down the mathematical name for this type of angle. The angle is greater than 90 degrees and less than 180 degrees. And so it is an obtuse angle. Measure this angle. Using a protractor, when we measure the angle, we get 134 degrees. Write down the mathematical name for an 8-sided polygon. An 8-sided polygon is known as an octagon. Work out the size of an interior angle of a regular 24-sided polygon. Here is the formula for the size of an interior angle of a regular polygon. In this case, the number of sides n of the polygon is 24. When we type this into the calculator, we get 165 degrees. The diagram shows a circle center O with diameter CE. A, B, C, D, and E lie on the circumference of the circle. Find the value of X. Give a reason for your answer. OA and OB are radii of the circle, which makes triangle OAB an isosceles triangle. Base angles in an isosceles triangle are equal. The sum of the angles in triangle OAB must add up to 180 degrees. So we have x plus 24 plus 24 equals 180. When we make x the subject, we get x equals 132 degrees. Find the value of y. Give a reason for your answer. An angle formed in a semicircle is 90 degrees. The sum of the angles in triangle ECD must add up to 180 degrees. So we have y plus 73 plus 90 equals 180. When we make y the subject, we get y equals 17 degrees. Draw a tangent to the circle at A. On the diagram, we've drawn the tangent to the circle at A. The diagram shows the front of Pranav's house. Work out the total area of the front of his house. The total area of the front of his house is equal to the area of the rectangle plus the area of the triangle at the top. The formula for the area of a rectangle is L times W, where the length L of the rectangle is 9 meters and the width W is 5 meters. The formula for the area of a triangle is half base times height, where the base is 9 meters and the height is 2.4 meters. When we type this into the calculator, we get 55.8 meters squared. The door is 0.9 meters wide and 2.1 meters high. Each of the 4 windows are 1.5 meters wide and 1.2 meters high. Work out the total area of the door and the 4 windows. The area of the door is equal to 2.1 times 0.9 meters squared, and the area of the windows is equal to 4 times 1.5 times 1.2 meters squared. When we type this into the calculator, we get 9.09 meters squared. Pranav paints the front of his house, but not the door and not the 4 windows. Work out the area he paints. To get this area, we simply subtract the area of the door and the windows, which we found to be 9.09 meters squared, from the total area of the front of the house, which we also found to be 55.8 meters squared. This gives us 46.71 meters squared. Pranav paints a wall of area 53 meters squared. 1 liter of paint covers an area of 4.5 meters squared. Paint is sold in 2.5 liter tins, each costing $24.75. Pranav buys the least number of tins to paint this wall. Work out the cost of the paint. First, let's find the liters of paint needed for the wall. We know that 1 liter of paint covers an area of 4.5 meters squared. We want to find the liters of paint for an area of 53 meters squared. This is what we are calling X. When we cross multiply and make X the subject, this is what we get, which is equal to 106/9 liters. Now that we have the liters of paint needed to cover the wall, we can find the number of tins of paint that will be needed. We know that 1 tin contains 2.5 liters of paint. We want to find the number of tins we will need for 106/9 liters of paint. This is what we are calling Y. When we cross multiply and make Y the subject, this is what we get. When we type this into the calculator, this is what we have. This means to cover the wall, Pranav needs to buy a minimum of 5 tins of paint. 1 tin of paint costs $24.75. So the cost of getting 5 tins of paint would be 5 times $24.75, which is equal to $123.75. The graph shows the cost C dollars of traveling a distance D kilometers with Sanvi's taxis. Write down the cost of a 4-kilometer journey. When we map 4 kilometers onto Sanvi's graph, we get $14. Complete this statement. Sanvi's taxis cost blank dollars for each kilometer traveled. When we map 1 kilometer onto Sanvi's graph, we get $3.5. Find the equation of the line. The equation of any straight line can be expressed in the form y equals mx plus c. In this case, y is c and x is d. We found the gradient m of the line in the previous question to be 3.5. The line passes through the origin, so c is 0. So we have c equals 3.5d. Krishna's taxis cost $5 to hire plus $2 for each kilometer traveled. Show that the cost of a 4-kilometer journey with Krishna's taxis is $13. The cost of the journey is equal to the cost of hiring the taxi, which is $5, plus the cost of traveling 4 kilometers, which is $2 times 4. This gives us $13. Find an equation for the cost C dollars of traveling D kilometers with Krishna's taxis. Looking at how we calculated the cost in the previous question, we see that the cost C of traveling D kilometers with Krishna's taxis is 5 plus 2D. On the grid, draw a line to show the cost of traveling with Krishna's taxis. To be able to draw a straight line, we need to know at least 2 points on the line. When we plug in d equals 0 into the equation we got in the previous question, we get c equals 5. So our first set of coordinates is 0, 5. When we plug in d equals 10 into the equation, we get c equals 25. So our second set of coordinates is 10, 25. On the grid, we plot these 2 points and connect the points with a straight line. Mrs. Singh wants to hire a taxi. She says that Sanvi's taxis are always cheaper than Krishna's taxis. Is Mrs. Singh correct? Give a reason for your answer. Use your graph to help you. On the grid, we see that after the intersection point of the two graphs, Krishna's taxis are cheaper than Sanvi's taxis. So we can say that no, because Krishna's taxis are cheaper for longer distances. A minibus can be hired from Draft's minibuses. The cost is $8 per hour plus $P per passenger. When the minibus is hired for 3 hours with 10 passengers, the cost is $61. Complete the equation. 3h plus 10p equals blank. From the question, we've been given 3h plus 10p to be 61. When the minibus is hired for 5 hours with 8 passengers, the cost is $80. Write this information as an equation. So similar to the previous solution, this will be 5h plus 8p equals 80. Solve your two simultaneous equations to find h and p. You must show all your working. Here we have the two equations from the previous question, which we've labeled as equation 1 and equation 2. To solve these two equations, we'll be using the elimination method. Let's start by eliminating h. So we multiply equation 1 by 5, which gives us 15h plus 50p equals 305, which we've labeled as equation 3. Then we multiply equation 2 by 3, which gives us 15h plus 24p equals 240. Now that we have 15h in equation 3 and equation 4, we can eliminate h by subtracting equation 4 from equation 3. This gives us 26p equals 65. When we divide both sides by 26, we get p equals 2.5. So now we can plug in the value of p into any of the equations to get the value of h. If we pick equation 1, we have 3h plus 10 times 2.5 equals 61. 10 times 2.5 is 25. When we subtract 25 from both sides, we get 3h equals 36. And when we divide both sides by 3, we get h equals 12. On the grid, draw the image of shape A after an enlargement with scale factor half, center 3, -5. First, we need to mark the center of enlargement, which is 3, -5. Then we need to move each vertex on shape A such that we are able to reproduce the enlarged image of the shape. Let's pick point A. To move from the center of enlargement to point A, we move 4 units downwards. To pin the new position of point A, since the scale factor is positive half, we need to move half the distance we moved initially and in the same direction. This means we move 2 units downwards. After repeating the same process for all the vertices on shape A, we are now able to map out the enlarged image of shape A. On the grid, draw the image of shape B after a reflection in the line y equals -3. So first, we draw the line of reflection, which is y equals -3. Then from here, we need to reflect the vertices of shape B in the line y equals -3. So for point A on shape B, since we move 1 unit upwards to touch the line of reflection, we also need to move 1 unit upwards from the line of reflection to pin the new position of point A. We need to repeat the same process for the rest of the points on shape B as well. When we are done, we are able to map out the reflected image of shape B. Describe fully the single transformation that maps triangle C onto triangle D. When we look at triangles C and D, we can tell straight away that this transformation is a rotation 90 degrees in the clockwise direction. So now we need to identify the center of rotation. In this case, we see that point C remains fixed after the rotation. So that is the center of rotation with coordinates -4, 4. And so the full description for the transformation would be rotation 90 degrees clockwise about the center, -4, 4. For the triangles shown on the grid, write down the letter of each triangle that is congruent to triangle X. Triangles congruent to triangle X must have the exact same size as triangle X. Based on this, we see that triangle J is the only triangle congruent to triangle X. Write down the letter of each triangle that is similar to triangle X. For triangles similar to triangle X, the ratio of their corresponding sides must be equal. Based on this, we see that triangle J, triangle F, and triangle H are similar to triangle X. The scale drawing shows the positions of a rock R and a statue S on a map. The scale is 1 centimeter represents 6 meters. Work out the actual distance between R and S. On the scale drawing, when we measure the distance between R and S, we get 9 centimeters. So we set up the scale conversion to get the actual distance between R and S, which is what we are calling X. When we cross multiply and make X the subject, this is what we get, which is equal to 54 meters. A flagpole F is on a bearing of 164 degrees from S. Work out the bearing of S from F. In the illustration, we've indicated the bearing of F from S, which has been given as 164 degrees. And we've also indicated the bearing of S from F, which is what we are finding. These two are interior angles. Interior angles add up to 180 degrees. So to get this angle, we subtract 164 degrees from 180 degrees, which gives us 16 degrees. Angles formed at a point add up to 360 degrees. So to get the bearing of S from F, we subtract 16 degrees from 360 degrees, which is equal to 344 degrees. Ishan uses the map to find some treasure T. T is on a bearing of 76 degrees from R and on a bearing of 337 degrees from S. Mark the position of T on the map. On the scale drawing, we first measure an angle of 76 degrees in the clockwise direction from the north of R. Then we measure an angle of 337 degrees in the clockwise direction from the north of S. An easier way to mark this bearing is to measure an angle of 27 degrees from the north of S in the anti-clockwise direction. The intersection point of the lines is the position of point T. The treasure is a bag of coins. The coins are made from 3 different metals. Complete the table. We get the sector angle for each category by dividing the percentage category by the total percentage, which is 100%. Then we multiply by 360 degrees. So for the first category, we have 70% over 100% times 360 degrees, which is equal to 252 degrees. Then for the second category, we have 20% over 100% times 360 degrees, which is equal to 72 degrees. Then finally, we have 10% over 100% times 360 degrees, which is equal to 36 degrees. Complete the pie chart. Using a protractor, we can start by measuring the sector angle for tin, which is 36 degrees. Then we measure an angle of 72 degrees for zinc. The remaining angle, which is 252 degrees, would be for copper. The grid shows the first 3 diagrams in a sequence. Each diagram is made using small squares that are white or gray. On the grid, draw diagram 4. We simply repeat the total number of boxes in the previous diagram as white boxes. Then we add an extra row of gray boxes at the top and an extra column of gray boxes on the right. Write down the term to term rule for the number of gray squares. When we count the number of gray squares in each diagram, we see that the term to term rule is to add 2. Complete the table. For the number of small white squares, we see that 1 squared gives us 1, 2 squared gives us 4, 3 squared gives us 9. So for diagram 4, 4 squared gives us 16. And for the nth term, we have n squared. For the number of small gray squares in diagram 4, we simply add 2 to 7, giving us 9. Since the terms in this sequence have a constant difference, we can use this formula to get the nth term. A1, which is the first term, is 3, and D, which is the common difference, is 2. When we expand the brackets, 2 times n is 2n. 2 times negative 1 is negative 2. 3 minus 2 is 1, so we have 2n plus 1. To get the total number of squares, we simply add the number of small white squares to the number of small gray squares. So for the total number of squares in diagram 4, we have 16 plus 9, which is equal to 25. And for the nth term, we have n squared plus 2n plus 1. This can also be written as n plus 1 squared. Work out the number of small white squares in diagram 18. The number of small white squares in diagram n is n squared. So for diagram 18, we have 18 squared, which is equal to 324. One of the diagrams has a total of 900 small squares. Work out its diagram number. The total number of small squares in diagram n is n plus 1 squared. So to get diagram n, for which the total number of small squares is 900, we equate n plus 1 squared to 900. When we take square root of both sides, this is what we get. When we subtract 1 from both sides, we get n equals 29. Another diagram has 43 small gray squares. Work out the total number of small squares in this diagram. First, we need to find the diagram that has 43 small gray squares. The number of small gray squares in diagram n is 2n plus 1. So to get diagram n for which there are 43 small gray squares, we equate 2n plus 1 to 43. When we subtract 1 from both sides, we get 2n equals 42. And when we divide both sides by 2, we get n equals 21. So now we know diagram 21 has 43 small gray squares. So to get the total number of small squares for diagram 21, we have 21 plus 1 squared, which is equal to 484. Write down the elements in set F. Set F contains elements that are a factor of 14. To get the factors of 14, we first list out the numbers that multiply to give us 14. So based on this, we see that the elements of set F are 1, 2, 7, and 14. Write down the elements in set P. Set P contains elements that are prime numbers less than 14. So the elements of set P are 2, 3, 5, 7, 11, and 13. Complete the Venn diagram. First, we start by listing the elements common to sets F and P, which are 2 and 7. After listing out the elements common to sets F and P, we see that the remaining elements in set F are 1 and 14. And the remaining elements in set P are 3, 5, 11, and 13. So now we can list out the elements that are in the universal set but cannot be found in either set F or P. These are 4, 6, 8, 9, 10, and 12. Write down the number of elements in F intersection P. From the Venn diagram, we see that the number of elements in this region are 2 in total. A number is chosen at random from the universal set E. Write down the probability that the number is in the set F union P. This probability is equal to the number of elements in F union P, which is 8, divided by the total number of elements in the universal set, which is 14. 2 goes into 8 4 times and goes into 14 7 times. So we have 4 over 7. Write 195 as a product of its prime factors. 195 can be written as 5 times 39. 5 is a prime number, so we circle it. 39 can be written as 3 times 13. 3 and 13 are prime numbers, so we circle them. So we have 195 equals 3 times 5 times 13. Thank you for watching. I hope you found this video useful. See you in the next video. Bye guys.